3 additional practice, okay? Comparing rate of change, initial value. Don't know what exact page this is in your packet. Hang on one second. I will tell you. In the meantime, okay, take a look at number 1, 2 linear functions, which you can't take a look at it because you don't know what page number it's on. But I'll tell you, I'm almost there. I'm almost there. And yes, it is. Page 45 and 46 in your binder, my friends. All right, here we go. 2 linear functions are shown below. Which function has a greater rate of change? Well, once again, rate of change is another word for slope. We need to find slope. Well, from a table, here we go. Choose any 2 ordered pairs. So we'll use the point 432 and the point 844. Remember, it's y minus y, x minus x. Let's take the big one minus the small one. So 44 minus 32 on the top, 8 minus 4 on the bottom. Comes out to be 12 over 4. 44 minus 32, 8 minus 4. 12 divided by 4 is 3. This rate of change is a positive 3. This rate of change, we need to find 2 good points on that line. Boy, there's not many good points on that line. Boy, oh boy, what a terrible graph they gave us. But we're going to make the best with what we got. Let's use this point right here, which is over 2 and up 4.5. Okay? And then let's use this point right here, which looks like it goes over 4 and up to 6.5. Well, let's find our rate of change here, my friends. Y minus y, x minus x. So 6.5 minus 4.5 on the top, 4 minus 2 on the bottom. This comes out to be 2 over 2. Now 2 divided by 2 is 1. Which one of those has a greater rate of change? Function A or function B? Well, I think it's pretty easy to see. That's function A. 3 is bigger than 1. Okay, moving down, number 2. Now we're looking at initial value. Well, initial value, when you look at an equation, initial value, y-intercept. There's your y-intercept. This has an initial value of 5. Now, when we were taught about tables and initial value, it's the value of y when the x value is 0. Well, here's your x value of 0. This would be your y value. Now, which one of those is bigger? 5 or 8? I'll go with 8 is larger than 5. Okay, number 3. Now we're determining whether or not a function is linear. Okay, linear means in a straight line, if it's graphed in a straight line, or has a constant rate of change. Now, from a table, let's look at our rate of change. Okay, now let's use these 2 ordered pairs, which once again is the point -2, 3, and 1, 0. Y minus y, x minus x. Now, y minus y. Let's start with the big one minus the small one. So 3 minus 0 as my y values. Bottom's got to be -2 minus 1. Well, 3 minus 0, 3. -2 minus 1, -3. If we take and divide this out, your rate of change for those 2 ordered pairs is -1. Now, to determine if it is linear, we have to see if that has another rate of change of -1 between 2 other pairs of points. So let's use these. X values, y values. So we have the points 3, -2, and 4, -3. Are you with me there? All right, y minus y. Take the big one minus the small one. So -2 minus a -3. On the top, 3 minus 4 on the bottom. Well, -2 minus a -3 is a +1. 3 minus 4 is a -1. And 1 divided by -1 is a -1. Now, it's linear if it has a constant rate of change. Are those the same? Yes, they are. Function number 1 is a linear function. Okay, that would graph in a straight line. Look at function B. Is this a straight line? could say is non-linear. Okay? Number 4, decide whether each function is linear or nonlinear. Again, linear just means graphed in a straight line. Nonlinear means maybe it's not in a straight line. Okay? Function 1, is that a straight line? No. It's nonlinear. Function number 2, is this a straight line? You got it. That is linear. What about this? Is this a straight line? No. It's non-linear. Okay, questions? All right, well, let's go to the back. Page 46. Ooh, which two functions have the same rate of change? Now, folks, we should be trained to look to see rate of change is the coefficient of the variable, or in this case, the number beside the variable. Well, let's highlight those numbers. 0.5, 4, 0.6, and 0.5. Well, which two have the same rate of change? Again, all we're looking at is the number beside the variable. That represents our rate of change. Which two are the same? Letter A and letter D. Yeah, good stuff. I thought so. Number 6. Glenn compares the rates of change of two linear functions represented in different forms. For a linear function in the form of y equals mx plus b, how does Glenn determine the rate of change? Well, if we were given a form or an equation in this form, what do we do to find the rate of change? Find the value of m. Okay, find the value of m. All we got to do is look at the number beside the variable. That will tell us our rate of change when given an equation. Y equals mx plus b. This number right here is our rate of change. Hey, letter B. How can Glenn determine the rate of change of a linear function presented in the table of the right? Well, how do we find the rate of change when given a table? You got it. Y minus y divided by x minus x. We find two pairs of points. Okay, 2 points from that table. Find our slope. Now, guess what? We get to do it. Yes, we get to find that rate of change. So let's choose 2. Which 2 you want?
The big numbers.
You want to use the big numbers.
I ain't afraid, Mr. Knoll.
Okay, so he wants to use the point 3, 18, and 4.
18's the best number ever. Might as well use it.
Debatable. Peyton Manning.
Facts.
Okay, y minus y. Well, let's take the big minus the small.
Yeah.
So 18 minus 16.
2.
Okay, x minus x on the bottom.
4 minus 3.
Started with 18.
4 minus 3.
Hey,
No?
if you're going to speak out, speak right.
Oh, why isn't it 4 minus 3?
Well, you got to subtract in the same order
Oh.
that you did on the top.
I hate when I do that.
Yeah, you can't do that.
You can't do that.
So you get a 2 over a negative 1. Now 2 divided by negative 1, negative 2 is your rate of change for that table over there. That's how you do it.
That makes sense.
Okay. Well, let's look at the next one. Critique, reasoning. Critique, reasoning. Critique,
Reasoning.
reasoning.
The more you say it, the more dumber the word gets.
Critique. The table on the right and the equation y equals 8x plus 5 describe linear functions. That means they both increase or decrease at a constant rate. A student incorrectly, probably a student named Ryan, incorrectly states that the initial values of the functions are equal. Compare the
Come
initial
on.
values. Okay,
Even
well,
I know.
let's
It probably was Abigail.
Initial value, 5. That's our y-intercept. Now, look at the table. What's our initial value?
Find it.
When the x value is 0, there it is.
Whatever number y is. 8.
What mistake do you think this student made?
Yeah, they saw the 8 on the slope and the 8 in the y, I bet.
They
Yeah.
used
Slope.
the slope.
Yeah.
value
You can't do that.
for the initial.
That's like triple stamp and a double stamp.
You can't do that. If you don't know what we're talking about, watch the movie Dumb and Dumber. You can't triple stamp a double stamp. You
Mm-mm.
can't triple stamp a double stamp.
Can't be
Lloyd?
done.
Lloyd? All right, number 8. The equation y equals 4x plus 60 in the table each describe a linear function, which once again means it increases or decreases at a constant rate. Compare the properties of the functions. Select all that apply. Well, Mr. Fricky, I think we better look at this one pretty easy. I wonder what our rate of change is in this table. Well, let's find our slope. Y minus y. I'm going to do 80 minus 60. Just using these 2 points on the bottom, 20 minus 10. That will give me 20 over 10. Now 20 divided by 10 is 2. This table has a rate of change of 2. This equation has a rate of change of 4. Okay? Now, initial value. Does this table, Mr. Fricky, can you see this? Does this have an initial value of 60? I mean, the table starts at 60,
Yeah.
right?
Gotta. No.
No, we got to find the value
0.
of
When
y
x is 0,
when
what is.
x
Yeah.
value is 0.
So go backwards, everybody.
Now, let's just go backwards. Hey, we're taking 10 off. So this is like a minus 10. From 40 to 30 is 10 down. This is taking off 20. 120 down to 100 is taking off 20. Does that stay consistent? Minus 10, minus 20, minus 10, minus 20. If I take 10 more off on the top, or my x value, how much am I going to take off on my y value?
20.
I'm going to take off 20. Well,
Yeah.
what's 60 minus 20?
40.
40. So your initial value for the table, or our value
40.
for B, is 40. We have a rate of change of 2, y-intercept of 40. Well, I'm going to erase this stuff now. This equation, y equals 4x plus 60. This is my rate of change. We'll call it the ROC.
Rock.
R-O-C. Okay?
Do you smell what the rock is cooking?
Is my IV, my initial value. Okay? If you don't want to use those, let's go back to Unit 2. Call this our B value.
B.
This our M value.
M.
Slope, initial value. All right, let's compare them. Are the linear functions described by the table, or the linear function described by the table has the greater rate of change? Well, here's the table, 2. Here's the equation, 4. No, 2 is not bigger than 4. Not choosing that. This one, the linear function described by the equation has the greater rate of change. Rate of change 4, rate of change 2. Yeah, 4 is greater than 2. Check box in that bad boy. The rates of change are equal. Well, if you choose this one and this one, come on, use some common sense. Okay? Can't do that. The linear function described by the table has the greater initial value. Initial value by the table, 40. Initial value of the equation, 60. Nope. The linear function described by the equation has the greater initial value. 60, 40. Equation, yep. And are the initial values equal? Well, once again, if we're saying it's greater here, we can't say it's equal. Whew, almost done, Mr. Friggy. Number 9, Jeff, my man, saving $500 from his summer job so he would have spending money during the school year. Smart idea. He withdraws, which means takes out $12 from his account each week. So a linear function models his plan because he's taking the same amount away per week. Melissa made a similar table, or a similar plan. The table shows her results. Compare the functions. Okay, Jeff, Melissa, what is Jeff's slope or rate of change? It's negative 12. Why? He's taking $12 out every week. Now look at that table. We can look at that table. Each week, as the weeks go on, what's happening to her account? That's our rate of change, our slope. Well, her account going down how much? $10.
10.
10. Okay? Now, our initial value. Jeff started with how much moolah? Jeff, he started with $500. His initial value, 500. Now, once again, be careful on this one. We got to look at week 0, not week 1, week 0. Can somebody look at that pattern and tell me what would be the value or the balance in her account at week 0? Well, week 1, she took out $10. So that means she started with how much at week 0? 520 big dollars. With that being said, which one has a greater rate of change? Jeff, even though his number is left, who's taking out more per week? Okay? Jeff is. He's taking out $12 per week, greater rate of change. Even though negative 12 is less than negative 10. He is taking out more. Who had a greater initial value? Who started with the most money? Jeff? No, because Melissa had 520 bucks. Okay, there's additional practice 3-3, page 45, 46 in your packet. Move on to the Math Excel. Hopefully you're in a good spot. Peace.